Hello everyone, welcome back to Page of Physics. In this particular video of vector calculus, we are going to see resolution of vectors. Okay, generally vector is some quantity which has magnitude and direction. Okay, so generally we draw vector like this. If this vector is A, and if I take the tail of the vector at the origin of the coordinate system, consider this as x-axis, consider this as y-axis, right? So the components of vector A along the x-axis, like here, okay, if this is theta, so component of A along this x-axis will be A cos theta, right? And component of A vector along the y-axis will be A sin theta, right? So this A cos theta and this A sin theta are known as the components of this vector A. Okay, as vector A has two components, one is A cos theta equal to A cos theta I cap plus A sin theta j cap. Okay, so A cos theta I cap plus A sin theta j cap. So I can also write it as A equals to x I cap plus ay j cap, right? So what is ay? Ay is the A sin theta, ax is the A cos theta. Okay, also this kind of components can be positive and negative also, right? Let us see resolution of vectors in much detail. So our first topic is Cartesian components in two dimension. Okay, so generally consider a vector like this, vector A. If I have two axes, one axis is here, x-axis, y-axis. Okay. Now, if this is angle theta, right, and I make two projections. Okay. One projection is, our first projection is, so firstly I took, so firstly we will consider the projection of vector A along the x-axis. Okay, now you can see that this is at 90-degree angle, right? And the length of the vector is known as the magnitude of the vector, which is A in the modulus, right? So this is the vector A, right? Okay, so if this is theta and this is hypotenuse, so I can put cos theta equals to, now this is cos theta, okay, and this is the adjacent side of this particular right angle triangle. Okay, so I can take it as ax. Okay, so cos theta equals to, I can put ax upon the hypotenuse. Hypotenuse is basically a mod, so you will get ax equals to a cos theta. Similarly, I can also make the projection of this vector A along the y-axis. Okay, so this projection of this vector along the y-axis can be named as ay, right? So now you can see that I can move parallelly this part to here. Okay, so this is also ay. Now consider again this right angle triangle. Okay, so if this is theta, so I can put sine theta equals to opposite side, which is ay, divided by the hypotenuse, which is a. Okay, you will get ay equals to a sin theta, right? So this is how we can resolve the component of vector in two dimension, right? Basically we can take here x and y axis. It also can be y and z, or also it can be x and z. Okay, also remember, if this is theta, okay, theta is here, then ax will be cosine component and ay will be sine component. If the theta is over here, okay, so in that case ay will be cosine component and ax will be your sine component. Okay, so that's how you can resolve the components of vector in two dimension. Apart from this, also you can be asked how to find the value of this theta. Okay, so here you can see that Now I can write vector A as axi cap plus ayj cap. Okay, so vector A will be cos theta I cap plus sin theta j cap, right? So this is how we can resolve the components of vector in two dimension. Okay, now if you want to find this angle theta, okay, so we have ax equal to a cos theta, ay equal to a sin theta. Okay, this is your equation number one, your equation number two. So by dividing equation two with the equation one, you will get a sin theta divided by a cos theta. Basically, this will be tan theta, right? So this is tan theta. Now here you can see that a sin theta is your ay component and divided by x. Okay. So in this case, you can see that tan theta will be your ay upon ax, where theta is the angle of vector A with respect to x-axis, right? So this is how you can resolve the components of vector in two dimension. Y-axis, consider vector here. Okay. So vector has magnitude of 5. Okay, and consider this angle theta 37 degree. Okay, now your vector. Now you are being asked resolve the components of vector A into x-axis and y-axis. Okay, so A has magnitude of 5 unit, right? So sine 37. Basically, sine 37 is your 3 by 5. So here you can see that vector A will have two components, one on the x-axis, y-axis. Okay, so if I can take, this is your ax, your ay. Okay, so cos 37 degree will be ax upon 5. So ax will be equal to 5 into cos 7 degree. Okay, so 5 into cos 37 is basically 4 by 5. This will be 4 unit. And similarly, you can have ay equals to 5 into and 37 degrees. So it will be 5 into 3 upon 5. So it will be 3 unit. Okay. So you can write vector A equals to 4 I cap 3 j cap unit. Okay. So this is how you can resolve the vector A in its two components in two dimension case, right? Now let us look into the Cartesian components of vector in three dimension. Okay. So here you are given vector A. Vector A makes angle alpha with x-axis. Vector A makes angle beta with y-axis, and vector A makes angle gamma with the z-axis. Okay. So the vector A can be written as axi cap plus ayj cap. Also, there will be a third component which is in the z-axis, az a cap. Okay. So the magnitude of this vector A will be A equals to square root of is ax square, ay square plus az ka square. Okay. Now also apart from this, unit vector of A will be a cap equals to vector A divided by its own magnitude, which is A mod. Okay. So here you can have axi cap divided by A magnitude plus ayj cap divided by magnitude of A plus azk cap divided by magnitude of A. So what is ax upon magnitude of A, ay upon magnitude of A, az upon magnitude of A? Okay. So basically the cos alpha will be equals to ax upon magnitude of a, cos beta ay upon magnitude of a, cos gamma will be z upon magnitude of a. Okay, so here you can write a cap equals to cos alpha a cap, cos beta a cap, cos gamma a cap. Okay, so this is your vector. This is your unit vector a cap with income. This is your unit vector in 3 dimension. Okay, which is cos alpha a cap plus cos beta j cap plus cos gamma k cap. Okay, so here you can see that the magnitude of unit vector is also 1. So here you can see that a cap is your unit vector. So magnitude of unit vector is always 1. So it will be cos square alpha, cos square beta. Apart from this, we can have also one different kind of identity, which is sin square alpha, sin square beta plus sin square gamma equals to 2. Okay. So that's how you can derive using the sin square theta plus cos square theta equals to 1. Okay. So equate this thing in this particular equation and you will get this particular identity, okay, which is sin square alpha plus sin square beta plus sin square gamma equals to 2. Okay, so that's all for the resolution of vectors in 3 dimension. Let us take one example of inclined plane, which is like this. Okay, consider one block of mass here. Okay, if this is angle theta, right, and the weight of this particular mass will be downward mg. Okay, if this is 90 degree, 90 minus. Okay. So the downward force will be here. Okay, if this is 90 minus theta, and here you will have one component along the incline of the plane. Okay, this is 90 minus theta, so this should be theta. Okay, if mg is over here and this is theta, okay, you can consider this as a right angle triangle here. Okay, if this is theta, this will be your hypotenuse, right? So the adjacent component of this mg will be mg cos theta. Okay, and this particular component will be mg sin. Okay, so that's how you can resolve the weight mg in these particular components. Okay, apart from this, there is one another force, which is normal force. Okay, from the Newton's third law. And okay, so here what happens is, like, mass m applies mg cos theta force in the perpendicular direction inside the inclined plane. Okay, same kind of force this inclined plane will apply on the block on the upward direction. Okay, so that's how we can resolve the components of this particular vector in different components. Thank you so much. Stay connected to the channel for further videos.